Okay, by composing the function, I mean this. We still have the same function. We've got a 4x squared, a 9y squared, a negative 2x, a 6y, and a minus 1. Every time I see an x, I'm substituting in an x minus 3. I see an x, I'm putting in an x minus 3. Every time I see a y, I'm putting in a y minus 4. A y minus 4. There it is composed. So that would have taken this ellipse, whatever that may have looked like, some kind of an elliptical function, and it would have just shifted it. It would still look exactly the same. We would have just taken and moved this to the right and up on our graph. Okay, so now you can take a verbal description. You know how to write the set of instructions to move it and how to compose that into the algebraic equation. Last thing is I'm going to give you a picture. We're going to do a mapping, which is numerical analysis. Okay, so here's our function. I didn't give you an algebraic rule for it. I just gave you a picture of it. What would this function look like if instead of f at x, I graphed the function at x minus 4? What happens if you replace an x with an x minus 4? Which way do you move the whole graph?
4 units to the right.
Okay, and we know that it's a horizontal because it's inside the function. We're moving the x's. Right, because we subtracted. Okay, so that means we're going to take every single point on here, x, y, and we're just going to move it over so the x's are 4 bigger and the y's are the same. So here's a key point, and I'm just going to highlight some key points here, and I'm going to list them. So negative 5, negative 5. That's kind of key. Negative 1, 5. 0, 0. 1, 2. 2, 5. And 5, negative 5. Okay, so there are my key points on that picture. And I'm going to move them all 4 to the right. So this point here, x is 5, y is negative 5. If I move it 4 to the right, I'm going to add 4 to the y value. I'm going to be at 9, negative 5. This point here, x is 2, y is 5. I'm going to move it 1, 2, 3, 4 to the right. I'm going to be at 6, 5. X is 6, y is 5. So these two, let's just connect the dots and keep track of what we're doing. That line just moved over. It's got the exact same slope. It just moved over. What happened to the point 0, 0? I moved it 1, 2, 3, 4 units to the right. It's right here at 4, 0. This key point, x is negative 1, y is 5. Move it 1, 2, 3, 4 to the right. We're at x is 3. Y is still 5. So that point, let's connect those dots. And last one, negative 5, negative 5. Well, if I move it 4 to the right, it's going to be right there. Okay, so there's our transformation. Okay, will you please finish these last two? I want a verbal description. I want you to write out the numerical mapping, and then starting with this original function, would you graph that? And then do the same thing for D.